So 3.6 is the chain rule, okay? So right now, the tricks that you know to derive are the power rule, okay, which is your basic derivative. Okay, we know the product rule, when two things are being multiplied. We know the quotient rule, okay? And our fourth trick is now going to be the chain rule, okay? So the chain rule, I'm going to get down to a good definition for you. Looks like this. Okay, so the chain rule is when you have parentheses. Okay, so if I have something that's in terms of something else, so something is written inside of it. Okay, all I'm going to do is I'm going to drive the outside, and then I'm going to multiply by the derivative of the inside. Okay, so if you don't like the notation, I did write this in a different notation. Okay, so anytime you have some stuff inside of parentheses with an exponent, okay, you can use the chain rule. So all you do is you do kind of a basic derivative, so the exponent goes into the front, the exponent. Okay, you subtract one. That's just, this right here is your basic power rule, right? The only difference is you have a quantity of stuff, okay? And then all you do is you then multiply by the derivative of the stuff. Okay.
So on the last assignment, when we had something on the bottom, but it was in the bottom, can you use this?
Yes.
We could use this to like simplify the bottom.
Mm-hmm.
So it's like the derivative of the stuff, the same thing as the sheet.
Yeah, on that first notation, yes. Yes. Okay, you ready for an example? Okay, so write down number 1. Okay, so I have a quantity. I do happen to have a 2 in the front, okay? So I'm going to start by deriving the outside. So can you tell me what is my stuff?
3x squared plus x.
Very good unison also. Okay, so I'm going to start by deriving the outside. Okay, so I'm going to have 3 times 2 in the front. Okay, so we have 6. And then what is my new exponent going to be? Good. Okay, so I derive the outside. Now I'm going to derive the inside. So what is the derivative of my inside stuff?
6x plus
6x plus 1. Okay. So when it comes to simplifying, I'm never going to touch anything that has an exponent. So that quantity that's squared, don't touch it. We're never going to FOIL beyond that. Okay, but I can multiply the 6 through that linear quantity. Yes? The first 6? The first 6 comes from 2 times 3. Multiplying those 3.
So it's kind of like the derivative of the big thing without the middle stuff.
Yes, exactly. So you're questioning my rule.
She just feels like it's only going.
Just go with it, please. We'll talk about it tomorrow when we have another hour.
So it's like you think of crappy things, just ignore that and then draw
Yeah.
times it by parentheses.
Right. Okay, so all I'm going to do in my simplification is distribute the 6 through that linear quantity, okay, the one that does not have exponents. So we're not touching the squared piece, okay? In calculus, you don't ever want to touch that.
So every time you do the n, like the thing in front times the far one,
Yeah.
always.
Well, depend. Yeah. Well, if there's nothing in front, then you don't multiply.
I guess you would consider 1.
Yeah, you would. Yeah. Okay. So what is 6 times 6x? 36x. And what is 6 times 1? Right. Okay, so this would be as far as you'd want to go.
Oh, awesome. Because that's as far as I think I'd be able to.
Okay. Not on this one, but eventually, yes. Yes. Okay, so can I choose another example? You ready for one more?
Yeah.
Okay. I didn't really. Okay, I got this. We're gonna have -2, 4x to the 5th minus 2 to the 4th power.
Okay.
Okay. So immediately we know it's a chain rule because there's a quantity, we have parentheses, and we have an exponent. Okay? And there's no way that you want to FOIL that out and put it into standard form, right? I mean, we could FOIL it out and put it in standard form and just do basics on it. But why would you do that when you can use a chain rule? All right, tell me what the first number is. -8 times
4x to the 5th minus 2.
To the 3rd times 20x to the 4th. Very good. Okay, so now what can I simplify? Okay, so what is -8 times 20x to the 4th? Good. -160x to the 4th times the quantity for x to the 5th minus 2 cubed.
Wow, it's a lot more fun when you get it.
Right?
So what do you do like nothing? Yeah.
To a nothing, there's no exponent? You can't, well, you would just distribute it and just do basic rule on it in that situation. So are you saying, like if it was like this with no exponent, then just distribute the 2 through and do basic?
I feel like that's one like.
Yeah, and then just do basic rule on it and drive each term.
Like bam. You don't get
No, don't do product rule because there's only one x there. I mean, you can do product rule because when you derive the constant, it'll turn into 0, but it's just basic. All right, let's make it a little bit more exciting.
Exactly. And that would be really like where we're at right now. Yeah, I really think we should like what happened, like take it slow. Yeah, we had that. Is that a square?
So I have a cube root. Okay, now a cube root is not any different than an exponential piece, right? Because I can take a root and rewrite it exponentially. Okay, what is the cube root the same as?
To the 1/3 power.
To the 1/3 power. So this is no different than what we just did. It just starts by looking different. Okay, so let's derive it. What's my number out front? What?
Oh, I was taught you.
1. So I have 1. Oh, like when I derive it. I see what you meant by 1. Okay. So when I do my deriving, I get 1/3 times 2x cubed plus x squared. What's my new exponent?
See, that one was kind of big.
Okay, so if I subtract 1, we get -2/3, right?
So you don't take away 1, you're only taking away 1.
Okay, now times the derivative of the inside. What's the derivative of my inside piece? 6x squared plus 2x. Okay, everybody good there? Okay, now when it comes to simplifying on this one, I can multiply my 1/3 through my quantity. But what's going to happen if I have a negative exponent? It's going into the bottom. So what's happening is I'm going to write this as a fraction. Okay, so I'm going to have stuff that's going to be on the top and stuff that's on the bottom. Okay, so if I'm looking at my 1/3, the 1 is going to exist on the top. The 3 is going to be on the bottom. Where is this quantity going to be? Bottom. This is a big one. Where's this quantity? Top. Okay, so the piece on the top is going to be 1 times the 6x squared plus 2x. Can we just go ahead and call that?
So you don't multiply like it. You just put 1 on top.
Right. Because it's going to be a fraction. Yeah.
Right. Just leave the 3 out.
Just leave it on the bottom. How do we do on that one?
I like kind of. Can we do another one like that just so that it sits in our brains? Wait, I don't get why one-third doesn't just go with.
Because if I multiplied the 1/3 through, I would get, this would turn out nice, which would be 2. That would be, but if I did it times the 2x, I would get a fraction. And you cannot write a fraction within a fraction. I would have a fraction over the top of it.
But it would be
Right, it would just be unsimplified.
So if the
Is that the end of your question? All right, let's try another one. The square root of negative 3x to the 4th. Yeah. That's it. Yeah, I don't know. That's as creative as I'm getting right now.
And that's it.
Okay, that's it. So that's all I got. So.
Okay, so that equals. Wait, so then do we apply that to the 1/2 power to the 4, so it's to the 2nd?
Wait, what?
So it's the square root, so that's to the 1/2 power.
Okay, yeah, I see what you mean. Hold on. Let's add a +1 here. I don't want you to simplify it that far. Sorry. So I'm going to add that +1 in there. Because I see where you're going. Because it could have just simplified and gone to a basic rule. So, rewrite this in exponential form. So, what is my new exponent? So, negative 3x to the 4th plus 1 to the 1/2 power. Okay, so now we're going to drive it. So, is it going to end up out front?
1/2.
1/2. So we get 1/2 times our stuff to the negative 1/2 times the derivative of my inside stuff. What's the inside? Negative 12x cubed. Good. Okay, so simplifying. Do you see I'll have 1/2 times negative 12x to the 3rd? Is that going to break nicely? Yeah. Yeah, 12 times 1/2 is just like negative 6, right? So I'm going to have negative 6x to the 3rd, and where is that going to be? On the top or on the bottom?
Bottom.
Does it have a negative exponent?
No, yes.
It's on the top. So we're going to have negative 6 exponent.
Oh, why is it that way? Like, why did the negative exponent show so?
So if I have a negative exponent on a quantity, that moves it into the bottom.
Yeah, but why? Wait, what? I'm so lost right now, Nolte.
All I did is I just did 1/2 times negative 12x.
But why are you doing that? I thought the 2 goes on the bottom and the 1 goes on the top.
Okay.
Why did you do that? I see now.
Okay, so can we go? Can we go 12x to the 3rd is on top? The 2 is in the bottom with the quantity. Yeah. Right? And now I move that to the 1/2. Okay. So now can I simplify
Wait, why is
that
it
further?
12x to the 3rd? I thought it was she simplified.
Well,
Okay, so now if I simplify this, I can divide by 2 because people weren't seeing that.
Wasn't smart. Literally 5 seconds ago, she had 6x.
Yeah, because it is. But she skipped a step. And I didn't see that, so she was explaining.
I was explaining how we got to the 6x. People were not getting there. Just divided by 2, right?
Are there going to be a lot of these questions?
There are a few, not a lot. So your assignment today.
Wait, so take the question.
Mm-hmm.
So if it wasn't like 1/2 and it was 3/4 instead, then we multiply 3 times like the 12, and then 4 would be in front instead.
3. Yeah, so you'd have a 3 on the top and a 4 on the bottom. Yeah.
So is there any situation where, like, you know, the negative exponent wouldn't be negative? Thanks.
When you're working with a radical initially?
Yeah.
No, it will always turn, yeah. Yeah, which will turn it, push it into the bottom.
So what if it wasn't a negative exponent? Like the 1/2?
Then it would just stay on the top.
So
You wouldn't have a fraction, right?
Did you post that yet?
Oh, I didn't? Dang it.
You could just try to